Welcome to Ask and Learn.
Okay, so in this question, we want to find the solution to this recurrence equation. So first off, the characteristic equation is going to be R4 is equal to 5R squared minus 5/4. So moving everything to one side, you have R to the 4 minus 5R squared plus 5/4 is equal to 0. So now the question is, how do you factorize this? So the first thing that you can do is you substitute R is equal to plus or minus 1, and then you'll notice that this thing would factorize, well, R equals to plus or minus 1 will make this left-hand side equals to 0, because this will become 1 minus by 5 plus by 4, so that's 0. What you will also find out is plus or minus 2 also makes this equation 0. So the factors of this is then you can factorize this as R minus 2 times by R plus 2, R minus 1, R plus 1 is equal to 0. And so then your roots are basically these ones up here. R is equal to plus or minus 1 plus or minus 2. So now we want to solve the recurrence relation. So our relation is then AN is going to be some constant times by, let's say, minus 2 to the n plus by alpha 2 times by minus 1 to the n plus by alpha 3 times by 1 to the n plus by alpha 4 times by 2 to the n. So then we'll use our initial conditions, which is A0 is equal to 3, which is also equal to, when we put n into these powers, so this will become 1, 1, 1, and 1, is equal to then alpha 1 plus by alpha 2 plus by alpha 3 plus by alpha 4. We have A1 is going to be equal to 2, because that's the initial condition. And then minus 2 to the 1 is just minus 2. Alpha 1 minus 1 to the 1 is just minus 1, so minus alpha 2. 1 to the 1 is 1, so plus alpha 3, and finally plus by 2 alpha 4. So A2, given by the initial condition, is going to be equal to 6. So then this is equal to 4 alpha 1 plus by alpha 2 plus by alpha 3 plus by 4 alpha 4. And finally, A3, which is equal to 8, which is going to be equal to minus 2 to the 3 is minus 8. So minus 8 alpha 1 minus 1 cubed is just minus 1, so minus alpha 2 plus by alpha 3 plus by 8 alpha 4. So we have a system of equations, in particular these sets of equations. We have these sets of equations. So how do we solve it? So you could just do the simultaneous equations and you get this really, really massive working out. Or if you know linear algebra, you can write this in terms of matrix notation. So this will be 1, 1, 1, and 1, minus 2, minus 1, 1, and 2, 4, 1, 1, and 4, minus 8, minus 1, 1, and 8. And then this is times multiplied by alpha 1, alpha 2, alpha 3, and alpha 4. And then this is going to be equal to 3, 2, 6, and 8. So this is this set of equations in matrix notation. So if this doesn't make sense to you, then you could just use, you can add like this and just, very slowly solve these equations. But this is a much quicker way. So this is the matrix notation. Then what you do is you find the inverse of this matrix, and then you multiply this vector by the left side. And what you find out is that alpha 1, alpha 2, alpha 3, alpha 4 is equal to 0, 1, 1, 1. So to find this inverse, I just use a online calculator. And yeah, I use Python specifically, and then you just multiply this, and then you get this vector right here. So you know that alpha 1 is going to be 0, alpha 2 is 1, alpha 3 is 1, alpha 4 is 1. So then your solution is an an is equal to minus 1 to the n plus by 1 to the n plus by 2 to the n. Now we have 1 to the n is just going to be 1. So it's just plus 1 plus by 2 to the n.